So if I want to know the slope, if I want to estimate the slope at 0, how would I do that? It looks nice and straight through here, right?
Yes.
So you could just draw in your book if you wanted to. You could draw the line, just continue it, and then rise over run. You just have to find a point that you feel comfortable using. So what do I mean by that? Do I have a pencil yet? So I'd say, okay, looks like maybe like this.
It's frozen.
I know. Thank you. I was trying to save y'all from watching me try to do this with no, I don't have enough hands. Alright. This is exciting. So then I do like this here and say maybe it's like that. Right? Let me start again. Alright, so I just drew in my approximation for the tangent line. Right? It's not perfect, doesn't have to be. It just has to be, it only has to be freaking positive. Right? And then I just pick some point. It looks like it almost goes through that point there, right? So I'm going to use that point. This is an approximation anyway. You guys kind of, does it go through any other point pretty well? Well, 0, 0, hell, shit. So what's the slope going to be? It looks like to me it's going to be 4. Yeah. That's all you need. It doesn't have to be better than that. You're doing this by hand. But you draw in approximation for the tangent, and I'm hoping we're able to do that. So a more interesting point would be like, well, 1 is not very interesting. What would you say, what would you approximate 1's slope to be?
0.
Don't even have to do anything, right? That's where it's relaxing for a second. It's not going up or down, so it's 0 slope there. Is that cool?
Yes.
Which means, it's interesting, if this is a profit function, where do I want to be?
Up there.
I want to be at 1. I want to be here, right? So that derivative equals 0 seems important. So we'll be doing that, because that finds the hills and the valleys. What about at 2? That's a little more interesting. You guys take a second and try, well, if you have the book, you guys don't have, oh, the booklets amongst this. So again, at 2, here's 2 right there. I just estimate what that tangent line would look like, roughly like that. Again, it's not perfect. It's not quite exactly right, but I don't care. And then I just see it. It's near to this point there, and it's almost that point there. So that's pretty good. It's a rough estimate of the slope. You guys kind of with me? All right, I like it. And whatever that is, I don't know. 1, 2, 3, 4, 5. Back 1, 2, 3. So negative 5 thirds. Yeah, cool. All right. How are we doing there? Is that all right? And of course, that is exactly like we did in section 2.1. That's the visual representation of what we did in 2.1, where we took points around the point that I was interested in and averaged those to be what the slope was, right? It's pretty much exactly what we're doing visually here. Okay, maybe. Any other questions from...
You said negative 5 thirds?
Yeah, negative 5 thirds, I would say, because it was up 5, back 3.
Right.
And I know it's negative just looking at it. Cool. All right. Anything else from that? I want to focus on that kind of problem, on number 4 stuff, right? All right. So let's kind of do a mixture of that first problem, and then I'm going to try to show you how it's... You don't have to be as precise. All right. What happened there? All right. Start off nice. Now this one... What is the slope at every point here? What is the slope at every point? What is that slope going to be? Negative 1. So what we're going to do is something that will hurt your brain if you're not careful. And you're like, dude, you've already hurt my brain so far. But this one you got to keep reminding your brain that you're drawing. I'm about to represent the slope. I'm going to draw the picture that represents the slope at every point. Do you understand what I'm saying? So what that means is, at every point below 0, the slope is negative 1. So what's the slope at negative 2? So I'm going to put a point at negative 1. So what I'm about to draw represents the slope at every point. And what people end up doing is they kind of end up mimicking the picture of the graph already there. No, the slope here is negative 1. The slope here is negative 1. The slope here is negative. So it looks like this. What's the slope up here?
1.
Positive 1. So now the slope here is positive 1. The slope at 2 is positive 1. So it's going to like this. Now what's going to happen at 0? What's going to happen? What do you think? Good. The derivative is the slope is undefined at 0, right? Because the slopes don't Agree, I love it. So it feels just like the idea of a limit. For the derivative to exist at a point, the derivative from each side has to agree. That's very interesting. Feels very familiar. Why does it make sense? Because derivatives are built off of limits. Right? Okay, maybe. So that one was almost too easy because that's algebra shit. That's straight lines. Just one of the straight lines, you're going the opposite way. Ooh. So let's try one like that. Yeah, buddy. So what you don't have to do is what we're about to do, because I really want to make sure you understand what you're doing. If I try to approximate the slope at, well, negative 1's going to be kind of hard, but we could try. So approximate slope at negative 1, so, you know, it's following here like that, maybe? You guys kind of with me?
Yes.
So then, how much? It's like going down 1, 2, 3, and over a half. Does that make sense?
Yes.
You guys with me? So that's negative 3 over a half is negative 6. So if I wanted to plot that officially, at negative 1, the slope is negative 6, which is, you know, down here with my scale. You with me?
Yes.
All right. So when they ask you to graph f prime of x, given the graph of f of x, you're graphing what the slope is at each point. So if the function is up here but it's going down, my f prime is going to be negative. It's got to be down here. Does that make sense? Yes, sir.
So you know how at the top of the absolute value you made lines because you're showing each one at the points? So if it's, let's say it was only asking for 1 point, would it just be a dot down there?
Oh, that would be a strange question, like graph just the slope at a point, then it would just be a dot like it started.
Yeah.
It would just be that dot. Graph the slope at negative 2. It would just be the value of the slope at negative 2.
Okay.
So what we're doing is we're making a new function out of it.
Yeah.
The f prime function is a function. It's a new function that defines the slope everywhere. This function is what you call like a step function.
Yeah.
Right? It's a very creative name. It looks like a step. Let's call it a step. So let's be less precise here. You with me? You don't have to be precise with these. One reason why I gave myself the scale is to try to do what we just did. So you see why I'm going to graph this where it is. Do you have a question, Frank?
Oh, yeah. You might be getting to this in a second, but one between 1 and 2, how it's up and it shoots down.
Between 1 and 2?
Yeah.
What about? Oh, I'm sorry. Here? No.
No.
There.
What's going on? Sorry. Between 1 and 2?
Yeah, because how it goes up and then just shoots back down.
Yes.
The slope is 0.
Yeah, right here the slope is 0. I love it.
Okay.
I don't know if that's your point, though. I don't think that's your point. What's your point?
No, like it's supposed to be the slopes between two points, right? So like it'd be the slope between 1 and 2.
One way to approximate the slope at like 1.5 is to look at the slope between 1 and 2, right? That's an approximation.
Yeah, what I was going to say, how would you graph how it's changing from 1 to 2 since it's...
Oh, okay. All right. So you're getting into something called the second derivative, which is how the slope is changing. I think that's what you're thinking about.
Yeah.
So now let's get this. Somebody just said a very interesting thing. A really good place to start with this. Now that we understand what we're doing, I want to put points that represent the slopes at those x values. So where is this slope 0? It looks like it's 0 about right here, right? So I'm going to plot a 0 there, right? Because right here it looks like it's flat. Is that cool?
Yes.
And where else can I plot a 0?
At 0.
At 0, it also looks like it's flat, right? So in pencil, my pencil's going through all the values that represent the slopes at those points on the function. So it doesn't have to look like this function at all. It just has to. So here, where's it going to be? Where's it going to be below the x-axis? Anywhere my function is going down. So that's the first thing to be careful. Is people just sort of like end up just kind of like retracing the graph, and that doesn't make any damn sense. Your slope is not positive here. It's really big negative. It's got to be way the hell down here. So what's going to happen? What's happening to my slopes, though? I think this is sort of like getting what you're talking about. Was that my slope is really big negative, but then what's happening to it?
Small.
It's getting less and less negative. So like right here, if I approximate the slope right here, let's just do this. It'd be down 1, 2, and over 1, 2, 3, like negative 2/3, right? It's very small negative. You guys understand? So like right here, I would do negative 2/3, which is like right there. So now it's coming in like this. Let's make it bigger. That's rough. All right. So as this is coming in, what's happening is slope is negative, but it's getting less and less negative. I like it. So it's sort of like when you hear in the news, the economy is, the rate of decreasing the economy is lessening. Okay, the economy is still going down, but it's not going down as fast. Do you understand? And we're all hoping it's going to do this instead of one of these. You guys understand? You hear that all the time in the news. The rate of unemployment, the rate of decreasing unemployment is increasing or something. It's like, oh my God, there's like a couple different levels of that. Anyway, all right. So what's happening over here?
It's increasing.
In fact, what's going on? So it's 0 here. Then it's getting positive, right? And then what's happening like right in the middle of this? Because right after this point it's getting smaller, right? So it gets bigger and then it gets smaller. So somewhere right in the middle there, it is the
highest slope.
biggest positive slope. I like it. Did you guys see that? Some of you guys know that's called the inflection point. But we're not there yet, right? That's called the inflection point, but we don't know that yet. So you guys, the slope is 0 here. Then it's very small positive, but it gets big kind of quickly. And then it's the biggest positive right there. And if we wanted to estimate that, I don't know, 1, 2, 3, 4, 5, 1, 2, 3. It's like 5/3. You kind of with me? So 5/3. It should really be way the hell up there, but let's not go crazy. It goes like that, and then it's got to come back to 0, right?
Yes.
Okay. So I never am going to make you do this problem and make it specific. Make it like, you have to actually do the slope. I'm going to make those 2 separate problems. I'm going to say approximate the slope at 2, and then you can draw a line and approximate it. And then this would be draw a sketch of f prime given f. So this height of this thing doesn't have to be exactly right. It just has to capture the idea. So why is that there? Because like we said, about right there is where the slope is biggest. And then what happens to the slope? It's still positive, but it's not as positive. You guys with me? So the rate of increase in unemployment is decreasing. That would be like, oh, please, unemployment, turn around. This is back in like 2011, 2012. Please, unemployment. Right?
Yes.
Yes? Okay. Maybe. Yes, ma'am. Yes, sir.
So we're using tangent lines to find these slopes?
Beautiful. Because tangent lines at a point, their slope is equal to the slope of the function at that point. Right? In fact, that's how we get the tangent line, is to first calculate the slope at that point. So every point on my pencil line technically represents the point of the slope of the original function there. Right? That's why I have a point here, because the slope of the original function is 0 there. So why is this down here? Because it's negative slope down there. Then it's 0 slope, then it's positive slope, and then it becomes... Now here, what happens to the slope?
It goes back to 0.
It gets bigger and bigger and bigger negative, doesn't it? So that just says, wah! There you go. That is really gross looking, but that captures the idea. So if you gave me that, I'd be happy. Couldn't help you. Can somebody tell me the original function? What do you think? It's about what kind of function? Yeah, negative x cubed. And what the function we just drew is about what function? Negative x squared. So some of you guys might realize that's the shortcut. The derivative of x cubed is going to be x squared. The rest of us, we're going to learn that. We're going to prove that soon enough after this first test. You guys are like, please, shortcuts, Jeff. All right. So this one's too easy. That's algebra. How would I graph the slope function?
It's a straight line.
Where?
Yeah.
Beautiful. I love it. So at -2. It's always -2 slope, right? Down 2 over 1. Right? Down 2 over 1. So it's -2 slope. So how do I represent the slope? Maybe you can even draw straight. I don't know. Well, it's easier to draw if you look there, Jeff. Oh, yeah, that's right. You guys with me? That was almost too easy to really get the idea. But now you guys try, obviously. Don't you love how we do that? Get a sheet of paper and just try to. You can see the points where things interesting happen, right? So you just make sure you guys start correctly.
Do you want an actual number line, or do you want...
No, well, I mean, I do want the x-axis, right? Why do I want the x-axis? Because where is it going to hit the x-axis? What points?
At the peaks and valleys.
Good. So, like, give me a point where it hits the x-axis.
-1.
-1. Where else?
1.
Not 1. No. Is the slope 0 at 1? Where else is the slope 0? Somewhere in here, right? Where else is the slope 0?
3.
3. All right, there. I got you started. Just a very rough sketch of what the slope is doing. So you must stay on top of your brain. Your brain is going to just start to do weird shit. Your mind has to go, brain, wait a minute. It's negative to begin with. So whatever you're drawing, better start off in the negative region, because that's got to be what the slope is.
So at this point, y-axis doesn't matter.
Yeah, the y-axis I'm not going to worry about, because I'm not going to make you calculate the slope exactly. I just want to see if you know the idea of what the derivative is. And while you're doing that, I'm going to give out the answer key for the practice test. Make sure you have a front and back on this. My printer likes to screw with me. So if I force you to, you could approximate the slope, for example, there, but I'm not going to. That's going to be a separate problem. Here you just have to capture the idea that where should your graph start? Really big negative, right? Because this is just going to get bigger and bigger negative, it looks like. So it's got to start really big negative here. And then it's just got to go through 0 there. That's why it's good to start with a 0, so you know where you're headed towards. Now in between here, what's true about the slope? Positive. And what happens right here? It's the maximum, and then it goes back to 0. All right, let me stop there for a second. You guys see that? You have to each step remind yourself, okay, the slope, it's increasing, so I should be drawing on the positive side of things, because that's the slope should be positive. The slope is biggest about right here. So that should be about where the highest point of that is, because it represents the slope. And now what's happening to the slope as you go around this corner, it starts to decrease until it hits 0. And then what's the slope do? It goes negative. Now what's going to happen now? Identify. So what are the key points? At least the key points are where the slope is 0, where it's flat. And then the next key points are where it's the maximum negative or positive. Where's the maximum, the biggest negative slope going to be at? It's not here. It's going to be somewhere. You can see definitely where it turns here, it turns. So somewhere in the middle of this here, right? Do you see that? We're going to, thankfully we have an algebraic way to find it, because I had to do it visually. I'm like, shit, it's in here somewhere? Somewhere? I don't know. Shit. So we'll have a way to do it. So about right, maybe at 2, let's say, or where it says X maybe, or just screw it, Jeff, doesn't matter. So what does that mean? What do I want to have happen around here? Around these X values? I want them to be where this does what? Good, where it bottoms out, so where it turns back up. So about right here, it's going to turn back up, and it's got to turn back up so it can go to 0. So all these things are working together. Find the zeros first. Those are your anchors. Then you can find where's the most positive, the most negative, and that tells you where you got to bottom out or top out, right? And now what happens after this point? It's flat, and then it starts to become really big positive. Get out of there, Jeff. There it is. All right. Go away. So I don't know. How many turning points does this original have? 3. So it could be like x to the 4th, right? And this looks like a what? X cubed. Very interesting. We haven't proved shit about that yet, but it seems like if I drew an x to the 5th, my slope function should look like x to the fourth roughly, right? We're going to prove that that's true after this first test. Everybody got a practice test? Make sure it's got two sides. Anybody need, answer key, anybody need a blank practice test?
So, what is the test? What sections?
Shit, so many of you need a blank practice test.
No, I got a question.
Yeah. You need a blank practice test?
I think I lost mine.
Oh, well then you don't get one. Sorry, but you had one, you lost it. Alright.
Chapter 1, chapter 1.
That's all, I ran out. Sorry. So now, if you want to, it's wide open. We can do a little bit of. I didn't want to test that. That's going to be a neat video.